We ended our last video on the bottom of Module 6, Lesson 5, page C. And I wasn't sure if everybody got the answer down because we kind of got cut off right in the middle. But we said that because there's other heights, the ball doesn't go from in the air from 0 seconds to a fourth of a second. It's going to have 0.1 seconds, 0.2 seconds, 0.3 seconds. It will have a height at all of those times. So as we were saying, that means that it would be continuous data because any decimal, not just the decimals listed, makes sense for the problem. And like I said earlier, we're not going to be graphing these. We're just practicing on the continuous and discrete data. And I do have to tell you, I have painters here today, so I'm sorry. I know you can probably hear the tape in the background, but I can't spare a day of not making videos. I have so many to make, so I'm sorry if that noise is annoying you. Okay, let's go ahead and go to page 2. So again, we're not going to draw the graph. We're just going to look at the table and decide whether it's continuous or discrete data. So remember, we zero right into the X column and say, are they going to have a week 1.5? Are they going to have week 2.3? Does that make sense? Total number of customers at week 1.3? No, that doesn't make sense. So this would be discrete data because the customers are counted each week. Customers are counted once a week. Shall we say that? Once a week. Week 1.3 does not make sense. So that kind of shows why we would not pick continuous data. Okay, so discrete data because the customers are counted once a week. Week 1.3 does not make sense. Okay, so if you didn't get that copied, you can hit pause. I'm going to go ahead and go to the next page. This one wants us to do a lot of stuff, but we're just going to decide whether it's continuous or discrete. So because it is a collection of points and the points are not connected, this would be discrete because the points are not connected. Okay, then the next page, this one, another graph, but this time the points are connected. So this would be a continuous set of data. So you could be like time. Where is he at time 1 minute? Where is he at time 30 seconds? Where is he at time 1/4 of a minute or 2.3 minutes? So since time could be a decimal, that could be an example of time. And this could be how far away from home he is or something like that. So this is connected points. So continuous data, remember we can draw it without lifting our pencil. So you can see I could draw this whole graph without ever lifting my pencil. Where on discrete, we have to lift our pencil for each separate dot. So continuous is connected points. We do not have to lift our pencil. Okay, so for finite, this is one of the last things we have to learn for this module. The rest of everything we're going to do in this packet is kind of a review to get you ready for the tests. So you might want to have a highlighter out again. So you make a list of items you want to buy at the grocery store. A set is a collection of objects. So that collection could be called a set. Each member of the set is an element of the set. So milk is an element, eggs are an element, apples are an element. And we use braces to indicate a set. So you always know it's a set whenever you see the set symbols. How many elements are in the set of items that you want to buy at the grocery store? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Since we can determine the exact number of elements, this set is called a finite set. So if I can count how many elements are in the list, it is a finite set. Now suppose that we want to list all the possible real numbers that exist in set form. So real numbers would be 1, 1.1, 1.11, 1.111, 1.1111111, 1 point, and then 1.2, and do all that. Do you think you'd be able to list all those numbers in the set? No way. No way. There's an infinite number of real numbers. We would not be able to list all those numbers. I'm trying to get the screen a little lighter, but it doesn't seem to be working. All right, I hope that's an okay color for you guys. It looks a little blue for me. So if I cannot list all the numbers, like I said, just think about these. And these are just the positives. Think how many negatives too. And then I could keep going with the ones, and then I could do 1.2, and then I could do 1.3, and then I could do negatives. I could never, ever list. There's an infinite number. I can't list all of them. So I would not be able to list all the real numbers. Real numbers go on to infinity in both directions, negative infinity and positive infinity. So infinite number of elements using our proper language. So it has an infinite number of elements. I could never list all of them. In this case, we would be writing as many real numbers as we could think, but we would never be able to write all of them. There's an infinite number of real numbers. Therefore, you cannot determine the exact number of elements in that list because it's an infinite set. Okay, so let's look at the next page. So this is like what you will have to do on the test. You'll have to determine if a set is infinite or finite. So if you want to turn off your camera right now and practice on these on your own first, that would probably be a good idea. I don't know why. Still trying to work on the light here. It's so blue. But I'm not sure how to make it less blue. So sorry. Okay, class. Oh, like I was saying, you might want to turn off your video right now. Go through these and try them on your own. Just write F or I for infinite or finite. And then check them. So I'm going to go over them right now. So dot, dot, dot means this list goes on forever. That's what we use those dots for. So this would definitely be an infinite set. Set of fractions between 0 and 1. Most students think, oh, I can count those. Oh, really? Look at these. 1/2, 1/3, 1/4, 1/5, 1/6. You think you can count all those? No way. They're all bigger than 0 and less than 1. That list is going to go on forever too, so that would definitely be infinite. I could never name all the fractions between 0 and 1. The set of multiples of 3 between 0 and 50. So 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and I could keep on going until I get up to, let's see, 3 doesn't go into 50. 16 times 3 is 48. But does everybody agree I'd be able to count them? I could write them all down. I'm just not going to take the time to do it, but I could write them all down and I could count them. I'm guessing there's probably going to be 17 of them, I think. 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, that's 10, 30, 33, 36, 39, 42, 45, 48. Yep, 17 items. So since I can count how many items there are, that means it's a finite set. It does not go on forever. So when you use the dots in between, that doesn't mean it's infinite. That just means I'm not going to list all the numbers. There's some numbers in between. But when you put them at the end, that's when it's infinite. So this is infinite. This is infinite. And this is finite. And I would just make as many notes as you can about this so you can go back and study it and not just look at an answer and go, oh, I wonder why I wrote infinite. The set of apple trees in big orchards. So yeah, I know that number would be really, really, really big, but guess what? You could still count them. If you had a lot of time, you could go around and count all the trees. It does not go on forever. Yes, I agree. It's a very, very large number. But since it does not go on forever, it is going to be finite. So the number of trees can be counted. You'd need a lot of time to do it, but it could be done. So the number of trees can be counted. Therefore, that is a finite number. The set of states in the United States whose name begin with A. Sure, we can count those. Alaska, Arkansas, Alabama. So definitely can be counted. So Alaska, Arkansas, Alabama, Arizona. I don't know. I may be missing one or two, but you can see the point. We could count them. The set of most interesting courses at Maricopa. So what you have to ask yourself, is the number of courses infinite? No, I could count how many courses are offered at a college, so that would be finite. Number of numbers between 0 and 1 would definitely be infinite. That would be like real numbers, 1/2, 1/3, 1/4, blah, blah, blah. So that would